In Chapter 12, we will focus on problem solving and reasoning. Here is the chapter outline, and we'll first talk about what is a problem, and then we'll go on to talk about various methodologies and perspectives used to understand problem solving and how cognitive psychologists try to understand the mental processes involved when people try to solve problems. This will include the Gestalt approach, some modern research, using analogies to solve problems, how experts solve problems. As you can see, this is the area that we're going to focus on in this lecture. We'll also end with creative problem solving and then creativity, mental illness, and the open mind. So let's first talk about what is a problem. Cognitive psychologists define a problem as an obstacle between a present state and a goal. A problem persists when it's not immediately obvious how to get around the obstacle. Of course, a problem is considered to be difficult. Cognitive psychologists focus on the mental processes that occur when people try to solve problems. One way of doing that is to understand how experts solve problems. Let's first talk about what is an expert. Cognitive psychologists define an expert as a person who, by devoting a large amount of time to learning about a field and practicing and applying that learning, have become acknowledged as being extremely knowledgeable or skilled in that field. You'll notice in this definition that it mentions a large amount of time. Do you have any idea how long it takes, how many hours it takes for a person to be considered an expert in their field? Well, it turns out that it takes about at least 10,000 hours of experience to become considered an expert. Experts solve problems in their field, and that's an important point because we're going to talk about this later. They solve problems in their field faster and with a higher success rate than beginners. Experts possess more knowledge about their field. So one question is, why are experts faster at solving problems than are novices? And why do they have greater success than do novices when it comes to solving problems? Well, one of the reasons has to do with how experts organize knowledge in their brain. Keep in mind that knowledge is organized in our head so that it can be accessed when it is needed to work on a problem. It turns out that novices organize information in their brain based on very surface or superficial features, whereas experts focus more on process or structural features. Consider this study that was done in the early 80s. You had a group of novices, and it turns out that these novices were physics students. And then you had experts, and these were physics professors. They were asked to organize problems just based on how they go together. It turns out that physics students organized them based on more surface features, whereas the experts organized them based on process or structural features. Not surprisingly, organizing knowledge based on structural features leads to more effective problem solving. So this is one of the reasons why experts can solve problems better than novices. And again, that is because of the way that they organize information in their head. Some other characteristics about how experts solve problems. One thing they do is that they spend more time analyzing the problem than do novices. And at first this seems to slow them down, but it turns out that spending more time early on analyzing the problem pays off for them later because they have a higher success rate than do novices. An interesting feature about experts is that they are no better in solving problems than novices when given a problem outside of their field. And this makes sense because the superior performance of experts is not a result of greater intelligence or greater innate problem solving ability. It's because of the larger and more organized information that they have about their own field. And that's why they are experts, but only in their own field. One disadvantage of being an expert is that experts tend to be less open to new ways of looking at problems. And this may be why younger scientists are more likely than experts to have revolutionary discoveries.